Hello, everyone. Now, we could sometimes be asked to find the limit from graphs, and this is where a lot of people might find some difficulty when it comes to understanding the difference between a one-sided limit and a general limit. So let's talk about it. So we know that we have a left-handed limit with a point. We also have a right-handed limit, and we have a general limit, right? Now, what is going on with each of these? So we know that one of them is one-sided, right? One of them, I look at a point and I look at one-sided limit. So I look at the limit as x approaches this point from the left side, for instance, like a left-handed limit. Or I could look at it from the right side, right? I could say, well, what is the y value, or what is the function approaching as x approaches this specific point from the left hand or the right hand? So I have one-sided limits, but I also have general limits, right? And the general limit is when I have the left-handed limit existing but also equal to the right hand limit, right? So both of them have to exist, but both of them also have to be equal. So left hand limit has to equal to the right hand limit for the general limit to exist, and it would be whatever that answer is. So if it's like left hand limit is 3 and right hand limit is 3, then the general limit is also 3. So let's have a look at this. Let's have a look at what this means in an example graphically. So if I were to look at, what is the left-hand limit? So left-hand limit as x approaches 4. Well, as x approaches 4 from the left hand, so if I'm approaching 4 from this side, what's going on? It looks like I'm approaching almost 3.5 in the function value, right? The y value. So my left-hand limit is 3.5. And what about if I approach it from the right side? So if I approach 4 from the right side, well, it looks like I'm approaching 2, right? So then I have 2 for my right-hand limit. Are these two values the same? Is 3.5 the same as 2? Now we can see that that's not. So then I say that the general limit does not exist. And it doesn't exist because these two are not equal, and they must be equal for it to exist. Now let's have a look at what happens when we're looking at the left-hand limit and the right-hand limit as x approaches 5. Sorry, not x equal to 5, as x approaches 5. Okay, so as x approaches 5 from the left-hand limit, let's have a look at that together. So 5 from the left, so here's 5, right? From the left side, it looks like I'm approaching 4. So then the y value approaches 4, so that's my left-hand limit at x approaches 4. And then the right-hand limit for x approaches, 5, not 4. As x approaches 5 from the right hand, it looks like I'm approaching 3. Now, again, we can see that they're both not the same. They're both not the same values. So then again, my general limit does not exist. Okay, let's have a look at the next one. So as x approaches 6, we can see that it's not a very obvious point. So I'm going to skip x approaches 6, and I'm going to do actually what happens when I'm looking at x approaches 7. So as x approaches 7, let's look at the right-hand limit and the left-hand limit. So the left-hand limit first, if I'm coming from the left side, then it looks like it approaches infinity, right? So then I have the y value is approaching infinity. And I'm not saying the y value is infinity. I'm saying that the limit where the y value that it's approaching is infinity. So the limit is infinity. Let's have a look at what the right hand limit would be for x approaches 7. So again, right hand limit, I'd come from the right side approaching 7, and it looks like I'm going towards negative infinity this time. So again, we see, okay, well, right hand limit and left hand limit are again not the same. So we say that the limit does not exist. Okay. All right, let's have a look at another one. So if I were to look at x approaches x approaches 8. Now 8 is similar to 6, but I will do this one, not for any specific preference. I'm just going to do 8 because, it's in order and it's kind of similar to 6, so why not? All right, so as x approaches 8, let's do that together. X approaches 8. Now, as x approaches 8, we can see that it's continuous, right? What does continuous mean? Now, I want you to remember that continuous means that the function does not stop, right? So some of these points, so all these points, we can see actually that there's a discontinuity in these three initial points that we considered. There is a discontinuity at the point of interest. So over here we have a and we're going to talk about what this means in the next videos. But just remember that this means that it's not continuous at this point, and we're going to talk about it a little more. But at x is equal to 3, 4, as well as 7. Sorry, 5, 4, 5, as well as 7. All right. So as x approaches 8, we can see that that from this side it's approaching. Let's have a look at that. It's approaching. I mean, it's not exactly 3.5 or anything. Let's estimate it to like 3.2. And then from the other side, we can see that it's also approaching that point because of this continuity, because of the fact that it's basically it doesn't jump and it's not at another place. So over here, it's exactly as well as from the right hand, it's exactly 3.2 as well. So do you see how the left-hand limit and the right-hand limit are exactly the same? That's why over here we say that, okay, because they're exactly the same, our general limit is then going to be that same value, 3.2. Okay. All right, let's have a look at one last kind of important one over here. Now we look at x is equal to 7. Sorry, over here, it's actually around 10. So I'm going to say as x approaches 10, what's happening at x approaches 10? Now, as x approaches 10, we can see that from the left hand, it's approaching, I'm going to approximate this to like 2.9 because it's almost like right there. So I'm going to say it's like 2.9. That's from the left hand. And then from the right hand, it's also approaching that value. Now, I'm not asking you because I know that with other units, you know that this is not differentiable at this point because it's a cusp. But remember, we are reviewing whether limits exist or not. So over here, the limit exists if the function approaches this value. So over here, the function does approach from both sides. This point over here, this value of 2.9. So then I'm saying that the general limit, since it's 2.9 from both sides, the general limit is also going to be 2.9. Okay, so key reminder over here, you can have one-sided limits. You can also have the general limits. If I'm asking you if the limit exists at a specific point, so if I asked you, does the limit exist at x is equal to 10? Then yeah, you'd say yes, the limit exists at x is equal to 10, and it would look like this. The limit as x approaches 10 of f of x, let's say this entire function up there was represented as f of x, then you'd say that the entire function as x approaches 10 is indeed 2.9. This is our general limit, and it only exists because the right-hand limit was equal to 2.9, as well as the left-hand limit, and they were equal to one another, and that gave us our general limit, okay? All right, everyone, I hope that helps, and I hope we'll see you in the next video. Bye.